In this exercise, we look at the integration of trig functions. Now, the situation will be quite straightforward, unlike when we were integrating in the previous chapter where what you were integrating didn't look anything like a log, didn't mention log. However, the result of integrating involved a log expression. Here, it's in this chapter now with trig, it's going to be really straightforward. It's going to be obvious that you are operating with trig functions, nothing tricky going on, because remember when we differentiated the trig functions, they turned into another trig function. So then it makes sense that if you're integrating a trig function, then it goes back to another trig function. Now, you can think of it, all questions like that the integral of any function is to find the primitive, to find the function that it came from before it was differentiated. Or, in this case, you can just look on the reference sheet, because all of these, these three, are on your reference sheet. The integral of cos of a little function in x will be 1 on a. Now, obviously, if a is 1 and b is 1, the integral of cos would be 1 on 1, which is just 1, and you wouldn't have it there. Sine 1x. So I'm sure you can understand that not every answer is going to have a fraction at the beginning of it, especially, like we just said, if the coefficient of the x is a 1. So it's 1 on a sine, because when we differentiate sine, it goes to cos, plus c, of course. The integral of sine, now remember, we don't get plus sine, we should get negative sine. More ideally, we would like minus sine there. However, we just know that rather than coming from a plus cos, it comes from a minus cos. And again, just taking into account the possibility that there could be a coefficient in front of the x other than 1. So you'll need to include the 1 on a plus your constant. And then, of course, the integral of sec squared of a function in x would be, again, the 1 on a tan the function in x plus the constant. Now, that's all, like I said, fairly straightforward, and those connections are there for you on the formula sheet. I think I'll just pause the video. It's not getting too long, so I'll pause the video and write up these solutions and then come back and talk about them. Okay, A is very straightforward. However, you've got to know that sec squared came from tan, so the integral of sec squared is tan, plus a constant. These are all indefinites, so we need our constant on all of them. The next one has a half cos of x dx. Now, the half is of no benefit. We don't really want it, or even certainly don't need it in here in this position. So we use the rules from the initial introduction into integration, which said that one of the rules was if you've got a constant, then you can take it outside of the integration. And so I've done that in this line, and then thinking about where cos x would come from, and we know that comes directly from sine. So keeping your half, integrating your cos, you get sine plus your constant, and you can always differentiate these to check, which I have checked that the solution is correct, which I have done in this next one. because let's have a look at it. Sine of x on 2. Now, to start with, we know that cos differentiates to minus sine. So we would have really liked a minus sign here. And we know that you would have to differentiate x on 2, which would introduce a half. So we've got a few things to take into consideration there. We know that there is no negative there, so there must have been a negative in the original function that it came from. We know that there is no half in here, and so there must have been a 2 to counteract that half. So, what is the primitive of sine of x on 2? It's negative 2 cos x on 2 plus a constant. You can see I've checked, and to check, differentiate what you've got. So differentiate this negative 2 cos x on 2. So differentiating that, I would have negative 2 cos differentiates to minus sine of x on 2, same thing, then multiplied by the derivative of this little function in x, which is a half. A negative times a negative is a positive, and 2 cancels with 2. We can't do anything. We actually can't access anything inside that sign operation. And we're left with the negative and negative made a positive, and we're left with sine of x on 2. Is that what we were asked to integrate? Yes, it was. Hence, our answer here must be correct. You should be right then to get started with exercise 4G, and do as many of these as you have time for, and you should find some of these in questions 1, 2 and 3 fairly straightforward.